So this is going to be a quick lecture on grayscale maps and dynamic range. That's our second of, I think, 4 in the series, Unit 3, 4, 5. So grayscale maps and dynamic range. We talked a little bit about this in class, and this is going to be a fairly short, quick lecture on this, and we'll go over this more when we look at the machine and stuff. So we'll talk a little bit about grayscales, what they do for our image and how to choose those, and the dynamic range and how that differs from grayscale, and how to colorize our image. You've seen that button on the machine, some of you did. So grayscale, what is it? So grayscale, if you define it, it's basically the number of shades of gray between black and white that can be used to display in our image. So the wider the scale rather of grays, the more grays can be used to represent smaller signal differences. And as far as that goes here, you're going to look on our screen and you're going to see up in the right hand corner on our machine, you're going to see a grayscale map. And typically at the top of that map, when the Philips products, it'll say map 2, map 3, map 4, whichever map you're using. And it'll have a dark to light band on it, so that depicts that particular grayscale, map 1, 2, 3, 4, 5, whichever one you're using. When we turn our color on, it comes right up beside our grayscale right over here. Okay. We have on the Philips product 5 grayscale maps. We choose them, and we choose them for the best composition detail for the image that we're looking at. So, but define machine setting, define the grayscale machine setting that adjusts what shades of gray are displayed on the image, basically. And the effect determines how the brightness of each shade of gray will be displayed in B mode, or quote-unquote brightness mode. Again, determines how the brightness of each shade of gray will be displayed. And here, if you see this image here, we have a gray map. They're calling it map F, and they're calling this map A, and you can see the difference between these two shades, where this one's a little more bistable and darker. This one's here just a little bit, you can see a little bit lighter here, and you can see the difference between choosing just the grayscale. You see the grayscale map here, and you see a grayscale map over here. We're going to depict this more clearly on the machines, of course, when we do that. So as far as we just choose our grayscale map, it's on the bottom of our screen, and we just click on that. We can choose whatever map we want to use. Dynamic range is another function we have, and most manufacturers refer to this as compression on the machine, as a button for compression. And when you turn your screen on, you'll see up in this corner up here, these compression will be listed up here, what percent compression it is. Either I don't know if it's percentage or not, but decibels rather. Usually at 50, we get a pretty good image. Define dynamic range compression, so the ratio between the highest and lowest received echo amplitudes in our image. And this determines the number of shades of gray. And the effect that it has on the image adjusts the appearance of the shades of gray on the image. So make sure you understand the difference between that and this here, where shade of gray adjusts how and what shades of gray we're having, and the brightness of each shades of gray, as opposed to dynamic range, which is the ratio between the highest and lowest received amplitudes in our image, which determine the number of shades of gray and adjust the appearance of the shades of gray on the image. And here's a pretty good depiction of what that is. Concept of dynamic range is the extensive useful ultrasound signals that can be processed to reduce the range of the voltage signals to a more manageable number. It is defined as the ratio of the largest to the smallest signals measured at the point of input to the display, and it's expressed in decibels. And here you can see where this box is determining the machine rejects a certain amount of images below this line here and accepts images above this line, and that there determines the rejection and acceptance determine the saturation level of the screen and the shades of gray and how dark or bright they're going to be. And this is your dynamic range that it has selected right here in these amplitude of signals coming back to the image from the back to the machine from the image to determine brightness of that image. It's all done obviously by either suppressing or accepting these amplitude signals coming back from our image there. If we set our dynamic range to a low setting, we get a very black and white image, a high contrast, or we call a bistable. If we have a high dynamic range setting, we get more shades of gray and similar range of amplitudes assigned to image, making image smoother and less contrasty, whereas the low DR would be high contrasty. And for test purposes, I probably know the difference between these two. And if we go back to this image here, we can see our dynamic range here is at 75 decibels. And our dynamic range here is at 50 decibels. And you can see here our image is a little bit darker than it is over here. This is allowing a little bit more and this is suppressing a little bit more. And we get more of a bistable image over here as opposed to a more gray looking image over here. We can define our border walls where you get the anteroseptal and infralateral wall down here. Make sure there are enough shades of gray to differentiate the interface between the different tissue characteristics to see the endocardium, and that's demonstrated right here where we can see the endocardium really well here. This is kind of foggy, too many shades of gray. This isn't too bad. This is you can see it pretty well here too. I kind of like this image here. All of these, this looks like a little too much gray and maybe not quite enough, or this is might be a little more bistable, but that's okay. We can still differentiate here. We can see our endocardium. When the doctors want to see, they want to see the endocardium. You see the inside wall of the left ventricle. That's what has to thicken in systole. It's very important for them to see that. So the key points here for the lecture, and we're almost done here. Grayscale maps adjust the brightness level of each shade of gray. Dynamic range determines number of grayscale values, a number of shades of gray displayed in the image. And then we can do the colorization thing if we want. Remember, we changed on the machine, sepia. We got a bunch of different colors we can choose from. You define colorization as to transform the grayscale to a different range of colors. The effect may demonstrate certain stuff, or pathology is a little better, colorizes the image only, no real change, only the perception of what we see. And here you can see we've turned on, we got grayscale map 1 over here, and we've turned on colorization. This is sepia. I use this color a lot. I don't know, just like it on my eye likes it or something, you know. Some people don't like it, so but that's all it is just pushing a colorization button on the machine that's on our front panel. Some of us have played with that. Okay, so it's a short lecture this week. Be sure and review this, and we'll be going over the other topics next week. Thank you.